Aloha, Rich Halverson here. This is ITS388. And so we're in the third week of the semester, and I've figured out my schedule. And my target is, I'm pretty sure this will be what the time is noon to 1 on Tuesdays. I'll be recording these weekly videos. I need to schedule. It's more because I need a schedule to make sure I keep up with you folks, so I don't end up holding you guys up. So anyway, let me share my screen. And so here's the syllabus, and we are in week 3. And I think I covered week 1. Well, I'm going to assume that we've covered these sections very lightly, and I'm going to go through all the way. I'm going to try to get all the way through, and I'll do a couple of the labs. Maybe I'll do the chapter 2 labs for us. Okay, so let's go to the book. And let's see, I had something that I wanted to make sure I got all the sections. Okay, so, makes me sign in. All right, so chapter 1 is very simple. This is ITS388, so you guys all know how to program. We're only learning Java, since we're learning Java on top of your already, pretty good programming skills. So you can read through this, and what's good about this chapter is that it sort of shows you the differences. It shows you how to do all the basic stuff, like, run a program, the structure of a program, all of the stuff you have to have around your code before you can actually start running code. And as you learned in this case, this is really the code part right here. And we have that public class thing above it, and then inside a public static void main thing called main, and then we write our code in there. And I think this goes on and shows you how to read from the input. You have to import the scanner, and then here is where you can read in something and see. So this thing reads what the user enters, and then declares a couple of integers. You have to declare them like this in Java, and once you declare them, you can't change them. And then so here we're reading in the input, and we're reading in an integer. In Python we have to use input and then put an int function around it. We just use this next int function that comes with scanner. And then, these kind of statements are the same, except for that you have to put a semicolon after each statement, okay? The other thing, of course, is that indentation doesn't matter. You don't need to indent anything. You can have your code like this if you want. It still works fine. So, anyway, and then these are print statements. When you say print, it prints it does not print with a carriage return automatically, and so of course in Python it's different. But if you do a print line, then it's going to print, it's going to print the carriage return at the end. New line. So that's what's good about this first chapter, and then you figured out how to do the challenge activities. I think I may have shown you that already. All right, and these exercises here just go through. See this, I go through these exercises I'm teaching 128 this semester also, and so I'm doing these same exercises, except for I'm doing them in Python, and sometimes I can't remember if I've covered these in the class. I know I've covered this already once this semester, but it might not have been this class. But you guys are more advanced, you're juniors now, and you can go in here and just read through this, and it's the same as what you learned before, and talks about steps. And so this is more about how
this textbook works. All right, so enough of chapter 1. Chapter 2 is where we start, you know, learning about variables. You have to declare the primitive variable types are the same. There's integers and strings and so on. But with Python, you have to declare variables before you use them. And so that's this chapter. Identifiers, the rules for identifiers is the same. Let me close this. The rules for identifiers is the same. Arithmetic expressions the same. You know, operator precedence, all that. Floating point number is pretty much the same. So you declare a floating point number double instead of int. It's double. And so these declares these variables, and here we're printing something out without a carriage return, and then we're going to read something in, and this is how you read in something that you want to be a double. And so here's some normal regular calculations, and here we're printing stuff out. So those are the different types. There's this constants are declared a little bit differently. I think you put this final. All right. I'm not used to doing that. I don't really use constants. I just use variables. But anyway, that's a good idea, good practice. So here you can do these. What is this? The cost to ship a package is a flat fee of 75 cents plus 25 cents per pound. Declare a constant named cents per pound. Oh, is that what I'm supposed to do? Here we go. I'm supposed to declare this variable, and it's going to be it's going to be an integer, I guess. Oh, down here. int this. Oh, I'm supposed to declare a constant called cents per pound. So I got to go final. And I got to say it's got to be initialized. You know, it's with equals 25. And get the shipping weight from the user. So we got to do the scanner and just so I don't get something from the user like this. Enter weight. And we want to store it in this variable here. So that's what goes here. And we did that. And then using this and this, we're supposed to compute this. Oh, we're supposed to compute that. So this is read in. This is a constant, and this is a constant, and this is something we calculate. So this must be calculated by going this equals it's weight, ship weight pounds times the cents per pound plus flat cents. And then, oh, so I guess we're outputting it in cents. All right. All right, I'm going to see if this is the right answer. It should be easy to, I mean, that's right. We are writing our program not in Python, but so you got to put semicolons after everything. Now what's wrong? Oh, sorry, it's an int. No, I'm sorry, it's an int. It's an int. It's got to be next int. INT. Now let's see if it works. Okay. All right. It doesn't want me to print anything. Okay, it just wants me to. Its comments are double slash. Double slash is a comment. How about this then? All right, very good. So make sure you do all these challenges, because you get points for those. You don't get points for clicking through the participation activities, although I notice a lot of you are, and that's the idea. It's an easy way to learn. You don't have to open up a book, or you don't have to do anything. This is just like pure knowledge in these little chunks, and you're done with this, and now you can go, make dinner or whatever. All right, see, so that was 2.9 constant variables, and then the next one is, it looks like there's a challenge activity on using math methods. And so here, this talks about there's math methods, and it's just like the math module in Python, except for you don't have to declare it up at the top. It's built in, and capital math, and then it's the same ones. It's all the same ones. Square root, power, absolute. In Python, it's FABS because of floating point. But anyway, so these are the math methods, and let's see. Type the program's output. All right. What is the square root of 36? I think it's going to print. It's going to. Oh, okay, right. It's giving me the format, and it wants me to put a carriage return after it. Yes. All right. So anyway, it's 6. It's 6.0. Enter. Let's see if this is right. All right, very good. What's this one? Okay, so you can do the rest of them. Compute that. If the input is 4, if x is 4, okay, the first thing it does is it reads x, and the next thing it does, it reads y, and then I'm supposed to compute z, I guess. I'm gonna start it, and z, because then it prints out z. So I go z equals math.sqrt parentheses x times y semicolon. I think this is right. Very good. Next one is this whole big one. Why not? Is that just one challenge activity? I'll leave this to you. Okay. You know, you do all this. I'd throw in some variables, extra variables, maybe make it more simple, or you can just write the whole expression. You know, they start out with math.sqrt, parentheses, and then you're going to do, you can do math.pow, parentheses, no, is there a square? Is there a square function? No, that's just something times something. Anyway, you can do that. You're experienced programmers now. This is not Java. This is, you know, solving the puzzle. All right. And math methods. Oh, modulo division. And see, is this the same? This, integer division does not generate any fraction. So, what are this determine the result? How do you, when the operands, when the operands of slash are integers, the operator performs integer division, which does not generate a fraction. Okay, so all you gotta do is make sure that both of the operators are integers. If you make sure both the operators are integers and you do that slash division thing, it'll be you'll just get the quotient result. Programmers may forget, causing strange logic errors, that this is always 0. Why? Because this is 0. It's not 0.5. It's 1 divided by 2. The quotient is 0. The remainder is 1. Anyway, so just keep that in mind. It's different than Python. Divide by 0. The second operand must never be 0 because you can't divide by 0. You'll get a runtime error. Oh, modulo, yes. So that's how you get the remainder. Where do we introduce that percent sign? Anyway, it's the same as Python. That's the same as Python. All right. Enter the output. See, I'm going to do this till 1 o'clock. So I'm going to spend half the time on this chapter and the other half the time on the next chapter, maybe. Enter the output of integer expressions. What? Okay, what's the output? Well, x, these are integers, so x is going to be 2. And since we have this here, then it's going to interpret the pluses as concatenating strings, and instead of adding. But anyway, so x is 2 space, and then whatever this is 2 plus 7 is 9 times 3 is 27. So this is 27. And you don't print there's no return. Just right? I guess so. Let's do a harder one. Let's do 4. Yeah, I know. You can't do this, but I can. What is this one? That's what I'm doing, right? Yeah. It's P. All right. So it's 5 and then y. What's y? Y is 5 mod 4, which is 1. So it's going to be 5 space 1. Okay, you got that? 5 mod 4. 5 mod 4 is 1 with a remainder of 1. Let's see if this is correct. All right, very good. What else is here? What's this one? The cashier distributes change using the maximum number of $5 bills. Okay. Cashier deserves change maximum required bills followed by $1 bills. For example, 19 years yields 3 5s and 4 1s. Just write a single statement that assigns the number of $1 bills to variable num1s. Given the amount change, hint, use the amount operator. Okay, what are you supposed to do? A number of ones. So we got the number of 5s. We have the number of 5s already. We're supposed to put the number of 1s. Okay. Num1s equals amount to change mod 5. So it's never going to be more than 5. The quotient of amount slash 5 is up here. This is an integer, and so is this. So this is the quotient, and this is the remainder. This will be between 0 and 4. And we'll get that semicolon. And so that looks good. Make sure you do those. What's type conversions? Of course, you're going to want to do some. There's implicit conversion, and they don't force you to do everything when it's obvious. But if it's not obvious, then you got to use type conversion. You got to say these are all. Anyway, so make sure you answer these. What is this? Number of items. Type the value of the expression given int num items equals 5. So how about this one? 5 plus 10 is 15 divided by 2 integer. What's the quotient of 15 divided by 2? Well, it's what 14 divided by 2 is, and that's 7. All right. This might be different. I bet you this is 15 divided by 2, but this is a floating point number. And they all have to be, everything's got to be integer if you want the result to be integer. Otherwise, it's going to be floating point number. And so this might be 7.5 because the remainder is 1, and 1 over 2 is 0.5. There we go. All right, very good. So you can do this typecasting thing by putting this in front of it, saying, treat whatever this result is right here, which these are integers, kids in family 1 and kids in family 2, they're both integers. And so when you add 2 integers, you get an integer, but you want to treat it like a floating point number because you want to compute an average number of kids per family, so you can cast the result as a double. And number of families you can cast as a double. And then it's like a double. And then so you can divide this, it's like a floating point number. Anyway, so that's that. I don't think there's that. Yeah, there is that. You just don't put the parentheses around it. All right, so that's this. Oh, common errors. I accidentally perform integer division on floating point when floating point is a 10. Yeah, so this is a thing. Common mistake. Okay, you can make sure you know how to do this. I'm gonna do go through the rest of these. I'm going to do this one, lab costs. All right. So in this lab, you are given, you're supposed to compute the how much it costs in gas to travel 20 miles, and then how much it costs in gas to travel 75 miles, and then how much it costs in gas to travel 500 miles. And what you're given, okay, so your program is supposed to output this, and what you're going to input to your program is the car's miles per gallon. This is 20 miles per gallon for your car, and the price of gas in dollars per gallon. And right now in the mainland, it actually is like around this price. I would know. I drive an EV, so I gotta think about the cost of a kilowatt hour today is about 40 cents. Anyway, so your program has to read this in, and then you gotta print out this, because for 20 miles per gallon at this cost per gallon, dollars per gallon, you do the multiplication and you get this. This is how much it costs to travel 20 miles. This is how much it costs to travel 75 miles. This is how much it costs to travel 500 miles. All right, so I'm going to bring up a whiteboard here. And let me do that one, and I'm going to clear it. Clear it first. Then I'm going to put it over here. There we go. Let's see. Okay, so we are given a we're given 20 miles per gallon, and we are given 3.159 or something dollars per gallon. Okay, we're given those two numbers, and then we're given, let's just to start out, I'm not going to start out doing the 20 miles per gallon. I'm going to start out doing the 75 miles per gallon one, so you don't get the 20s mixed up. Okay, so and then we have 75. I'll do this one in 75 miles. Okay, that's what we have. So this is miles. That's miles. Okay, so now, so if we have, okay, and we want dollars, and the variable is dollars, so it's the result that we want is dollars. Okay, so we would like, all right, so we have a miles per gallon, whatever we want the result, we want dollars on top. And so how do we, okay, so if we can figure out a dollars per mile, we can figure out a dollars per mile, then when we multiply it by 75 miles, then the miles would cancel and we would end up with just dollars. That's what we want. Okay, so we want to figure out how to make this formula, how to compute what the dollars per mile is. So that's how much it costs this many dollars to travel 1 mile, and then all we have to do is multiply that by 20, and we get the 20 miles, and we multiply 75, and multiply 500. And so how do you get dollars per mile? Well, first of all, there's and we have to get dollars per mile from these two numbers. Okay, well, first of all, we want dollars on top, so let's put $3.159 per gallon. Now, what we would like to do is multiply this by, I'll do it on this side, multiply this by and we would like to have miles on the bottom and gallons on the top. So we want something that's miles on the bottom and gallons on the top. Why? Because then the gallons will cancel and we'll end up with dollars over miles. So So we need gallons over miles, gallons over miles. Well, we don't have gallons over miles. We've got miles over gallons. So how do we get gallons over miles out of miles over gallons? Well, we just take 1 over 20. So really what it is it's 1 over 20 times this 1 over 20 gallons. Let's go. Oops. Yes, gallons per mile times 3,159 dollars per gallon, and then these cancel, and we end up with 1 over 20 times 3.159 dollars per mile. So that's so 1 over 20 times 3.159 is 3.159 over 20, whatever that is. We can compute that. But anyway, this is dollars per gallon. So then all we got to do is multiply this number times 20, and then times 75, and then times 500. Okay, so we want to, this is reading in the dollars per gallon, and this is for reading in the miles per gallon. So let's go back to our thing here. We are going to write our code here. So first of all, we need to read in, let me make sure I get the right thing here, because I don't want to start you down the path and then have to backtrack, and then everybody gets all confused and I get completely confused. All right, so let's, we need we've initialized the scanner. Let's start out by saying add, and I'm going to go back up and initialize variables afterwards, but we have to start out with, we have to say we're going to use the scanner first. So we're going to say scanner, and I'm going to call it SCNR. That's going to be the handle of the variable I'm going to use for that, is a new object name, new scanner, and from system dot in. Yeah, that's just something you have to memorize after you write a bunch of Java code. Okay, and then I'm going to do a bunch of declarations, and then I'm going to read in miles per gallon, miles per gallon equals excuse me, SCNR dot SCNR dot next, and I'm reading in double values like this. I might as well declare it miles per gallon. So I'm going to have to do this for all of them. That just declares it as the variable. I also going to read in, next I'm going to read in dollars per gallon, and that's going to equal SCNR, next double that. Okay, and then I'm going to compute dollars per mile. Dollars per mile equals, let's get this right, MILE equals, I said it was going to be dollars per gallon. Remember we want dollars on top, divided by the miles per gallon. Instead of multiplying it by, you divide it by, because we're flipping it over. It's actually, we can do it this way. Equal this times 1 over that, where this is 1 over miles, this is 1 over miles per gallon, because we want the reciprocal, and then this, we multiply that by dollars per gallon, and we get dollars per mile. right, because this is on the bottom. Miles is going to be on the bottom, dollars are going to be on the top, and the gallons cancel. We showed you that. All right, so these are our three things. And then we're just going to print, we might as well compute these out. Dollars for 20 miles equals 20 times dollars per mile. Geez, I got to make sure I'm putting these settings. And dollars for 75 miles equals 75 times dollars per mile, and dollars 500 miles equals 500 times dollars per mile. And then after that, we can just print everything. And I'm going to use this printf method here, system out printf. And my format is going to be floating point number 2 digits. So I do %.2f 3 times, yeah. Like that, and I'll throw a carriage return after that. And what I'm printing out is dollars 20 miles, and then I'm going to print out dollars 75 miles, and then dollars 500 miles. I think this is pretty good. And now I got to declare all these things. I've declared this one. I got to declare this one as a double. And let's see, I got to declare, I'm going to do this. Copy paste, copy paste, copy paste, copy paste, copy paste. So miles, dollars per mile. Dollars per mile, dollars 20 miles, dollars 75 miles, and dollars 500 miles. Okay, so now here I've declared all the variables. I've read in miles per gallon, read in dollars per gallon, and I compute this dollars per mile number, which is how many dollars it takes to drive 1 mile at 20 miles per gallon at 3.159 cents or dollars per gallon. And so then I compute the 3 and print it out. Let's see what this looks like. I'm going to copy the input. No, that's not the input. I'm going to copy the input, and I'm going to paste it here and run it. Scanner, I mean, of course I meant that. All right, well, anyway, that looks pretty good. You can submit that. I'm going to leave it unsubmitted, just whatever. Okay, this one, this is phone number breakdown. And so there's different ways we can do this, and there's different, and we see this problem more, we see different versions of this problem in different sections of the book. I can't remember if we're going to see them again, because Zybooks gives me lots and lots of these labs, and so I change them every semester and stuff. So anyway, but in this one they want us to use integer division and the integer division and the integer modulo functions to get all these the different components. And so so we might as well get this one started. And I guess we're going to use long. Nice. Okay. So I'm going to, there's more variables. This is what's read in, and then we're going to print out this. So I'm going to, this is what's read in, and then I'm going to, and I'm also going to, from that, I'm going to compute long. This is the area code. And that's going to equal, that's going to be, that's all. I'm not going to initialize it as anything. There's going to be an area code, and there's going to be a, an exchange. They used to call those the exchange. Yeah, the exchange, long exchange. And then there's the 4 digits. And I'm just going to call it long. It doesn't have to be long. Maybe you want to keep them all consistent. Last 4. How's that? Last 4 digits. Last 4 digits. There we go. Those are the 3 things. And then I'm going to want to write out, at the end, I'm going to want to print out system out print line. So I'll print the carriage return, and I want to do, first I want to do this, and then I want to, and this is not, yeah, by using plus signs, there's not going to be any spaces in between. So first I want first I want the area code. So that's going to be area code plus, close the parentheses and put a space. And then I'm going to plus the exchange. So we used to call it back when I was a little boy, we called it the exchange. Exchange. And then we want to concatenate a minus sign, a hyphen, and then we want to concatenate the last 4 digits. And I think that's about it. So let me, so I'm going to do an experiment here to see if that looks right. I'm going to say area code equals 808. And I'm going to say exchange equals 371. And I'm going to say last 4 digits equals 7424. Okay, random phone number. And let's see what this says. It's going to be a random phone number. Don't, you people out there not in my class, don't like go call this number now. There won't be an answer. I don't answer phone numbers I don't recognize. Anyway, so run this. And it would look like that. Okay, very good. That's how it would look if that were the input, but of course, I'm not doing any code. Well, let's try to throw some code in there. The area code is going to equal, the area code is going to equal phone number, integer division, this would be 10, this would be 100, this would be 1,000, this would be 10,000, this would be 100,000, this would be 1,000,000, this would be 10 million. Okay, so I want to hack off the bottom 10 million, the bottom 7 digits, and so it's 10 million. Okay, that's the area code. And what's the exchange? Well, the exchange is, first I'm going to do mod 10 million. So I get the lower, first I'm going to do mod 10 million. So I get the lower 7 digits. No, is that a 7 digits? So it's, the exchange is going to be, phone number. That's right. I was gonna, I should have done this from the beginning. I'm gonna make it bigger so on the recording it looks better. Yeah, that looks pretty good on the recording. All right, I'll try to remember to do this. Okay, so it's gonna be a phone number, mod 10 million. I wonder where I type when I type it. It doesn't go anywhere. 10 mod 10. So that's going to be the lower 7, and then I want to hack off the lower. Then I want to do integer divide 10,000, and that will that'll take the 7 digits. That'll take these 7 digits and divide by 10,000. Yeah, 10,000. And that's going to hack off the lower 4 digits, and we'll just end up with the 555. Oh, let's see. Let me just submit this because I want to show you. I want to point something out. It looks like I might only get through this chapter, so I might make another video. I just want to point out. I'm running this because I want to. There's probably going to be errors, but I'm running because I want to save it. All right. You should look at where does it talk about still style guidelines? Okay, that's style guidelines. You should look at style guidelines. They recommend putting spaces in, before and after all the operators, one line per, one statement per line, make it look like this, not like this. And, it's purely a personal preference. This is a good practice. A lot of people like this practice. And if you use this practice, no one's going to fault you for it. Personally, I learned how to code back before we had to do any of this stuff, and just a line was a statement. So you could put the statements on a line. In fact, my first job, we had to make punch cards. Anyway, so when they started, when we started sort of self-documenting our code by indenting, I don't remember that. That was in the that was in the late 70s when they started doing that. So I like the indenting part, and that was adopted. But I had the chairman of my PhD, my dissertation, was a real minimalist type, and he was minimalist in everything he did, and he didn't like white space, so he would compact his code up real compact up, and he indented and everything. But there are advantages to that. Once you learn how to read it that way, you can have a lot more code on one screen. That's one advantage. And if you're writing the code, that's probably just fine for you. So you'll notice that when I write my code, sometimes it looks kind of sloppy or something, or not the way you would do it. That's fine. Do it the way you want to do it. Do it the way it looks good for you. I am never going to say anything about that. Okay. So let's go back to what I was working on here, and we'll just finish this up. So we have now we have. Can I make this bigger? Oh yeah. So now I was going to divide this by 10. Oh, okay. So I have to divide this by 1,000, 10,000, because we want the last 4 digits. You may see a pattern. 1, 2, 3, 4, 5, 6, 7 digits. We want to hack this line. We want to hack off the lower 7 digits. Okay, here we want to we want to just here we want to keep with a percent sign. We want to keep 2, 3, 4, 5, 6, 7. 7, I guess. This just keeps the lower 7 digits. This hacks off the lower 7 digits. Okay, so this is the lower 7. This is the lower 7 digits, and then this will hack off the lower 4 digits from the lower 7 digits. So it's only going to leave the upper 3 digits, and that's what the exchange is. And then so the last 4 digits is going to be, we can just do a phone number, and we only want to keep the lower 4 digits. So that would be modulo 10,000. So I think that is, and then you can go and put spaces in there. So if you think that looks nicer, what do I need? They've all been declared. Okay, so now I'm going to run this. I should get exactly the same answer. But if instead I put 800, 5, 1, 2, 1, 2, I should get all right. So you should be able to submit this, and that's pretty much all I'll cover in chapter 2. Make sure you go in and do all the learn about random numbers. We'll use them later, and integer overflow. Learn about that. When we get into how we handle exceptions, we'll look at that. Anyway, so that's chapter 2, and next video I will look at chapter 3 for us, and I'll do that before the next Tuesday. So next Tuesday at this time, noon to 1, I'll do another video. If you'd like to join in, that'd be great.